Today we will talk about differentiation formulas and examples, applying it to algebra. After today's lesson, you should be able to determine the derivative of algebraic functions thoroughly. We now apply the definition of the derivative to some algebraic functions to obtain the following results. That the derivative of any constant c with respect to x is 0, that the derivative of x to the n with respect to x is equal to n times x to the n minus 1. For the sum or difference of functions g of x and f of x, its derivative with respect to x would be equal to the sum or the difference of the derivative of each of these functions. Hence, we have the derivative of f of x with respect to x plus or minus the derivative of g of x with respect to x. The derivative of a product of functions f of x times g of x with respect to x is equal to the sum of the product of one function with the derivative of the other. This would give us f of x times the derivative of g of x with respect to x plus g of x times the derivative of f with respect to x. Dealing with the derivative of the ratio of f of x to g of x with respect to x, we will have this equal to the denominator g of x times the derivative of the numerator f of x minus the product of the numerator f of x with the derivative of the denominator g of x. This difference is to be divided by the square of the denominator. Hence, we have the square of g of x. When we are differentiating a power where the base is some function of x, where we have here the function u to the n, then its derivative with respect to x is given by n times u to the n minus 1 times du dx. Now, we have to remember that u is a function of x. Now, the rule given in number 6 applies to differentiating the square root of u with respect to x, or differentiating a power u to the 1 over n with respect to x. So, following the general rule, the derivative of the square root of u with respect to x would equal du dx divided by 2 the square root of u, and the derivative of u to the 1 over n would equal 1 over n times u to the 1 over n minus 1 times du dx. Okay, let us now work out some examples. For number 1, we have the function y is equal to 5x to the 4th minus 6x to the negative 3 plus 4x plus 7. In differentiating this function, we will be applying the following rules. That the derivative of any constant with respect to x is 0, that the derivative of c times x to the n with respect to x would equal c, a constant, times n times x to the n minus 1. Okay, and if we are dealing with a product, then its derivative with respect to x would equal the sum of the product of one function with the derivative of the other. Hence, for number 1, if we are to differentiate the given function y to obtain y prime, then we need the derivative of the said expression with respect to x. Okay? Since we have here a sum of functions, then what we need to do is to differentiate each of these terms with respect to x. And what would apply differentiating the first, the second, and the third terms would be this rule given in number 2. Hence, the derivative of 5x to the 4th will just be equal to 5 times 4 times x cubed, or that will give us 20x cubed. As to 6x to the negative 3, the derivative would be equal to, okay, 6 times negative 3 times x to the negative 4. But this is a negative term, hence we have positive 18x to the negative 4. And as to the derivative of 4x, that would just be equal to 4. And for the constant 7, it will be 0. So for our first example, the derivative of the given function y is 20x cubed plus 18x to the negative 4 plus 4. Doing another function, here y is defined product of 3x plus 4 with 4x squared minus 3. Recognizing that y is a product, its derivative would be done using rule number 3. So we have dy dx, or y prime, is the derivative of the product 3x plus 4 times 4x squared minus 3. Applying now this rule, we will have the derivative dy dx equal to the first factor 3x plus 4 times the derivative of the second function plus the product of the function 4x squared minus 3 with the derivative of 3x plus 4. This now will lead us to the following result. We have 3x plus 4 times the derivative of 4x squared is 8x. The derivative of negative 3 is 0. So for this expression, its derivative is just an 8x. For the second term, we will have 4x squared minus 3 times the derivative of 3x, which is a 3, plus the derivative of 4, which is a 0. Hence, we just have there a 3. If we are to simplify this, multiplying the factors as indicated, this now will give us 24x to the 24x squared plus 32x. Here is a 12x squared minus 9. Okay, and combining similar terms together, dy dx, or y prime, is equal to 36x squared plus 32x minus 9. Okay, for our third example, we will be differentiating the function y given by 4x squared minus 3 divided by 1 minus 2x. In differentiating these functions, the following rules would apply. That the derivative of a constant with respect to x is 0. That the derivative of a constant c times x to the n with respect to x is c times n times x to the n minus 1. And the derivative of a ratio f divided by g with respect to x would equal g times the derivative of f with respect to x minus f times the derivative of g with respect to x divided by g squared. So working out the derivative y prime, we differentiate this ratio with respect to x, and we need to apply number 3 rule. Hence, we will have the denominator 1 minus 2x times the derivative of the numerator 4x squared minus 3 minus the numerator 4x squared minus 3 times the derivative of the denominator 1 minus 2x all over the square of the denominator 1 minus 2x. Working out the derivative as required, the numerator now would result to 1 minus 2x times 8x. 8x is the derivative of 4x squared minus 3, coming from the derivative of 4x squared, since the derivative of 3 is 0. For the second term, we have 4x squared minus 3 times the derivative of 1 minus 2x, which is just a negative 2. This difference to be divided by the square of 1 minus 2x. Multiplying the factors as given in the numerator, this now gives us 8x minus 16x squared, and then this factor multiplied by negative 2 would lead us to having now an 8x squared minus 6. Okay, now this to be divided by 1 minus 2x squared. So simplify the terms of the numerator by combining similar terms together. This will give us now a negative 8x squared plus 8x minus 6 all over the square of 1 minus 2x. Or you may write it as product of negative 2 with 4x squared minus 4x plus 3 divided by the square of 1 minus 2x. In summary, in differentiating functions, we did not go through the 4 steps suggested by the definition of a derivative. Rather, we can just apply appropriate differentiation rules, which are the results of applying the definition of the derivative on some algebraic functions. Okay, so this is all for today. I hope to see you in the next lesson.